I fairly certain, am I recording right now? Or yes, okay. So I promised you guys a video of this continuity stuff because it just doesn't make sense, which is understandable. So you can see here on the right, I made this nice little flow diagram, flow chart, whatever you want to call it, to basically walk you through the steps for continuity, but also still help you with the justification piece because I realized a bunch of you can find it on a graph. So, like, here's a graph, you know what to look for on a graph. But then when it comes time to putting it together, then your brain just doesn't know what to do. So, I'm going to make one video with algebraic ways of doing this, and then I'll do another video with graphical ways to do this in case one makes more sense than the other. I might even just like steal some from Delta Math for the graphical one and walk you guys through them using my diagram here. So we have a piecewise function here. F of x equals x cubed minus 2x plus 1 when x is less than or equal to 2, and you have 3x minus 2 when x is greater than 2. If you wanted to be that person, you could just go ahead and graph it on the coordinate plane, and you'd be able to see the exact type of discontinuity. But as per the diagram on the right here, the chart, let's just go in order of the steps that you need. The first thing you should find are your left and your right limits, and find them in that order from the left and from the right because you read a graph from left to right. So the limit as x approaches 2, you're using 2 because your equation says less than or equal to 2 and greater than 2. So x approaches 2 from the left, put the little minus sign of your function f of x, pick the function on the left, the x squared, x cubed minus 2x plus 1. So you just plug 2 in. 2 cubed minus 2 times 2 plus 1. So 8 minus 4 plus 1. 8 minus 4 is 4. 4 plus 1 is 5. Now you find the limit from the right. So the limit as x approaches 2 from the right of f of x is going to be, you plug it into 3x minus 2. So 3 times 2 is 6. 6 minus 2 is 4. So we found the left and the right limits. We know that they are different because 5 and 4 are not the same. So that tells me, and yes, you have to write all of this because I know someone's going to ask. This together says the limit as x approaches 2 of f of x does not exist. And because the limit does not exist, that just automatically says and should register in your brain that x equals 2 is a jump discontinuity. Justification being the limit does not exist. But you need to make sure I see math for the left and the right limits, no matter which problem you are doing. So jump discontinuity because the limit does not exist. Let's try the second example. So now we just need to find our limit on the left and our limit on the right. So we're doing 0 again because x is less than or equal to 0 and x is greater than 0. I already pre-made the number lines for these, but you're just basically saying, here, use the x values they gave you. They gave you 0. And then it's either the ones that are smaller than 0 go on the left of 0 and bigger than 0 go on the right. Now we find the limit as x approaches 0 from the left of this function. So you plug 0 into 4 minus x squared. So 4 minus 0 squared, you get 4. You find the right limit as x approaches 0 of our function, and you get 4 plus 0, which just gives you a value of 0. So we found our two limits. We got 4 plus 0 is 4. Oops. When math teachers can't add. You had 4 and 4. So since the left limit and the right limit are the same number of 4, that tells us that the limit as x approaches 0 of f of x is going to equal 4. So now that we know we have a limit that exists, via my diagram here, the next thing you should find is your y value. So to find the y value, look for the equation with, so for y value, you're looking for the equation that has the like x is something or equal to something. So it could be greater than, less than, whatever. So it's that or equal to whatever number that it is that's there. In this case, x is less than or equal to 0. So to find your y value, you just find f of 0. And the only equation that 0 could work is the less than or equal to equation. So you got 4 minus 0 squared, which is just 4. So we have our limit, we have our y value, and we figured out that our limit equals our y value. So to put all of this together, we say we are continuous at x equals 0 because the limit as x approaches 0 of f of x is equal to f of 0. So the limit and the y value are the same thing. So that is why we say we are continuous. And yes, you have to write that out in limit notation and in words. Let's try a third example here. We have, these are on the easier end of the spectrum. The ones that you'll have to do will also be this level of problem. So we have a function f of x. We got x is less than 8, and then we got x is greater than or equal to 8. So my number line starts with 8 in the middle. So now we find the left limit and we find the right limit as per the diagram. So you have the limit as x approaches 8 from the left. What does that equal? And then the limit as x approaches 8 from the right. See what that equals. So from the left, you have negative 2 times 8 plus 19. Negative 16 plus 19 is 3. On the right, it's automatically 3 because anywhere that x is 8 or up, the y value is just going to be 3. So we know left limit and right limit are both 3. So the limit as x approaches 8 of f of x is equal to 3. Now that we have the limit equaling 3, we need to find the y value. So all you have to do is find f of 8. And we know that it's going to be 3 because that's the one that has the greater than or equal to symbol attached to the 8. So we know our limit is 8, our limit is 3, our y value is 3. So put that all together and we know that f of x is continuous at x equals 8 because the limit as x approaches 8 of our function is equal to our y value when x equals 8. So the limit x approaches 8 equals f of 8. So we are continuous. Okay, example 4. Same number line idea. Now let's do for x equals negative 8. So you find the left and the right limits as per always. So we have the limit as x approaches negative 8 from the left equals something, and then the limit as x approaches negative 8 from the right is also going to equal something. From the right, it's automatically negative 6 because anytime x is bigger than -8, it's -6. So from the left, we plug it into 3x plus 18. So we have 3 times -8 plus 18. And -24 plus 18 gives us 6. So on the left, our limit is 6. On the right, our limit is 6. They are the same. So our limit is going to exist when x is approaching -8. So you have the limit as x approaches -8 of our function is equal to -6. So now we need to find the y value. So we need to find f of -8 to compare it to the limit. So you have f of -8. We look for the equation that has the or equal to -8. In this case, it's the first equation because x is less than or equal to -8. And we already plugged it in before and did the math, and you get that the value would be 6. So because, oops, oh my gosh. Wait, yes, I'm correct. Okay, oops, typo. That should say -6. So my limit is -6. My apologies. So this should also say -6. Because -24 plus 18 is -6. So my limit is -6. My y value is -6. So what that says is my limit equals my y value. So I am continuous at x equals -8 because the limit as x approaches -8 of f of x is going to equal the f of -8, which is our y value, when x equals -8. But as I said before, if you truly want to check these, you can graph them all. You can graph them and like set the intervals you're looking at on Desmos. There's a way to do it. I don't 100% know how to do it, but it can be done because I've seen teachers do it before. So now we have f of x equals something when x is less than 6 and something when x is greater than 6. So draw your number line, find your left limit, find your right limit. So the limit as x approaches 6 from the left of our function is going to be -4 times 6 plus 9. -24 plus 9 is -15. Now the limit as x approaches 6 from the right of f of x is going to be -5 times 6 plus 15. So -30 plus 15 is -15. So we know that my limit exists because the two values you got are the same. So the limit as x approaches 6 of f of x is -15. Because left is -15, right is -15. So the two-sided limit is going to be -15. So from this, what do we know? We have a limit. So now that we know there is a limit and a limit exists, let's find the y value. So you're going to find f of 6. So you look for the equation that has an or equal to in it. And as you can see, this one strictly says less than, this one strictly says greater than. There is none that says or equal to, so there will not be a y value when x is equal to 6. So f of 6 does not exist. So since my limit does not equal my y value, I have a removable discontinuity. If you were to write all of this math out, and you got the limit here, and then the d and e part here, I would be fine with you just writing this piece. -15 does not equal d/n(e). So I can follow and say the limit is -15 and the value, they're not the same thing. So because the limit and the y value are not the same, there's a removable discontinuity at x equals 6. You must do this in the order I'm instructing you to do it. Your answer will not make as much sense if you don't. Because if you just say that because there is no y value at 6, there is a hole or removable discontinuity, your explanation would be wrong, because on a graph you could have open circle to the right, open circle to the left. I have seen it before. It doesn't make mathematical sense, but it has happened just for the sake of graphs. So make sure you start with the limit and then you go to the y value portion. So now we have this example. Example numero 6. Wait, yeah, 6 is 6. Example numero 6. To do this example, you need to look at two things before you start. You see you have two functions that look like fractions. So here's one, here's another one. Because they are fractional functions, they are rational functions. So rational functions, if you remember, have asymptotes. So let's check these for asymptotes before we even start doing our number line and all of the math that follows. So in the land of discontinuity types, we have whole, removable, and jump. Removable is a whole. We have removable, jump, and infinite. Infinite means vertical asymptote. And rational functions have asymptotes, so check for vertical asymptotes. And if you remember, a vertical asymptote is your denominator equal to 0. So let's start with our first function, the negative 18x over x plus 3. So we have x plus 3 is equal to 0. So you get that x equals 3 would be a vertical asymptote. You have to check that it's in your domain. So we got x equals -3, and -3 is in fact less than or equal to 3. So that means x equals -3 is an infinite discontinuity, just because it's a vertical asymptote. And that can be your justification. X equals -3 is a vertical asymptote, which explains why it's an infinite discontinuity. Now let's look at the other equation. We got x over x minus 2. So x minus 2 equals 0. So x equals 2 should be a vertical asymptote. But in this case, we cross it out because 2 is not bigger than 3. So it's not going to be an asymptote in the area of the function that we are looking at. So now that we've got all asymptotes out of the way, back to the number line portion of our equation. We got, here's 3. On the left, you got negative 18x over x plus 3, and you got x over x minus 2. So my limit from the left of 3 of my function is going to be negative 18 times 3 over 3 plus 3. So 18 and 18 is 36, and 18 is 54. Yes, so you have negative 54 over 6. You get negative 9. And from the right, you have the limit as x approaches 3 from the right of our function is going to be 3 over 3 minus 2. So 3 over 1 is just 3. So on the left is negative 9. On the right is 3. So this says the limit as x approaches 3 of f of x does not exist. So because my limit does not exist, that means x equals 3 is a jump discontinuity. So the final answer for this problem is x equals negative 3 is an infinite discontinuity, and x equals 3 is a jump discontinuity. Explanations being, for the infinite, x equals negative 3 is a vertical asymptote. For the jump, the limit as x approaches 3 of my function does not exist. And let's just do one last problem. We have here, oops, wrong, okay, 0, 1, and there's 3 possible function pieces. So let's start with x equals 0, because we do not see any rational functions, so there's no asymptotes to really worry about. So we start with the limit as x approaches 0 from the left of our function, and we're going to get 0 plus 2 is 2. The limit from the right of f of x, make sure your limit notation looks nice and beautiful, is also 2. So that says my limit is going to exist because 2 equals 2. So the limit as x approaches 0 of f of x is 2. So now I have to find, my limit exists, find my y value. So I just find f of 2. And then you have f of 2, you look for the or equal to, and it's not f of 2, it's f of 0. My apologies. Look for the or equal to, which is here, x is less than or equal to 0. So 0 plus 2 is 2. So my limit is 2, my y value is 2. So put it all together, and I am continuous at x equals 0 because my limit as x approaches 0 of my function equals my y value of my function. So now let's worry about x equals 1. My limit as x approaches 1 from the left of my function is going to be 2. Look on the left. And my limit as x approaches 1 from the right of my function is going to be 1 squared plus 2, which is 3. So from this, the limit as x approaches 1 of f of x does not exist because 2 does not equal 3. So if my limit does not exist, I have a jump discontinuity at x equals 1. I'm going to answer one of the questions that I got in the survey because the other ones were already answered. Someone said if the limit exists, so a limit existing could be, here's a circle, open circle, and the graph meets up coming from the left and the right at that open circle. Or it could be a closed circle with the graph meeting up there from both sides. If it's closed and the graph meets up, this is continuous. If it's open and the graph meets up, this is a hole or a removable discontinuity. If it's circle, circle, graph, graph, where the graph doesn't meet, that's a jump. And you could also find those pictures on the resource on the right that I'm going to upload to Google Classroom for all of you. Please enjoy the rest of your Sunday if you're watching this on Sunday, or whatever day it is that you decided to watch this.